So we have this file from Blackboard, right? The reference sheet, which basically it's like a cheat sheet. It has all the formulas and everything you need. Okay, so I have that for the averages. For the average, if we want to calculate anything related to the average. I don't have this for the proportion of a characteristic of interest in the population. What I want to do is to go over this problem I have put here. So just read the problem, finding out what the problem wants, what is given to us, and what is the best formulation to pick, what is the right formulation to pick here to solve the problem. And if you can make that recognition, then the rest is just putting the numbers in the formula and finding out the final values. So there's nothing tricky about it. So I have a couple of problem statements here. So what I want you guys to do is let's go over each problem one by one. And then I'll ask you guys what the question wants, what are the things that are given to us, and what is the right formulation to pick, okay? So please start with this problem. So I'll give you a minute to read the problem statement, and then I'll ask you questions. So the first question I have from you is that, what is that characteristic of interest? What is our random variable in this problem statement?
Time it takes to park the car.
Time it takes to park the car. And okay, and for this characteristic of interest, what am I trying to test? Is it something related to the average of this characteristic of interest, or some proportion related to this characteristic of interest?
Average, right?
Okay, how did you make that conclusion?
Because it's saying there's a claim that it's saying the average is this. So
exactly. So it says
percentage.
Exactly. We want to test if the average time to park is less than this value. So if time to park is a random variable, we want to run a test on the average of this random variable. Average time to park is less than 35 or whatever. Okay. So then I'm interested to run a hypothesis test on average. And my null hypothesis. So can you tell me what is my null hypothesis here?
Mu equal to 35 seconds.
How did you make that conclusion?
Well, they're saying the claim is it's less than 35. So that's the H1.
Yeah.
Mu would be equal to.
Exactly. So let me. So mu equals to 35. And our alternative hypothesis is that mu is less than 35. Okay, so that's my null hypothesis, my alternative hypothesis. What else do you get from this problem statement? What other pieces of information are given to you?
X bar and standard deviation.
Okay. X bar what does X bar show?
The average of the sample.
Average of the sample. Okay, what is the sample size?
14.
Okay, so it says the Toyota asks n equal to 14 people to do the test. So our sample size is 14. And then what is average of sample, or X bar?
13.
it says here, the sample average here, you see? The sample average is 30. And another piece of information here is, it says sample standard deviation.
S equals 12.68.
Exactly, that's extremely important. That you know that's S, that's our sample standard deviation. Okay, now, is there anything else that is given us to in this problem that I think we have everything, right? Yeah, I think we have everything. Okay, so these are what we learned. What is the random variable of interest? We are interested to run a test on the average and nothing related to a proportion or something. This is my null hypothesis. This is my alternative hypothesis. My sample size, average of the sample, and the standard deviation of the sample. This is extremely important. Okay, so now, obviously, the very, very first question is to figuring out this is something related to the average. We already did that. Do you remember what is the next important question that we have to ask ourselves to figure out which question which set of formulations we have to pick? After I know it's something related to average, what is another important question that help us to figure out what type of formulations I have to pick?
If standard deviation is given.
If the standard deviation is given or not, if I have the sample standard deviation or if I have the population standard deviation. Here you see explicitly it says sample standard deviation is this much. So that's sample standard deviation, that's S. Okay, so when we see the sample standard deviation, then we know that we have S. However, there is also another important question. When you have the sample standard deviation, okay, you know you have S. What is another important question that you have to ask yourself here?
If n is less than 30.
Related to the sample size. If sample size is small, meaning that if n is less than 30, less than and actually equal to, I believe. Yeah, less than equal. If n is less than or equal to 30, that's also a question that we have to ask ourselves. We don't have the sample, we don't have the population standard deviation, so we have to use sample standard deviation, which is S. However, we still have to know if the sample size is small or large. And here, the sample size is small because n is less than or equal to 30. Okay, so now with all this information that we have, if I go to the reference sheet here, which formula I have to pick? Let's assume I want to run a hypothesis test or construct confidence interval. Okay, let's assume I want to run a hypothesis test. Should I pick the top row or the bottom row?
You should choose the bottom row.
Bottom row, because it says here population, we are running a hypothesis test on the population mean mu, sigma, which is a standard deviation of population, is unknown, and n is less than or equal to 30. Okay, if that's the case, then, which is exactly the case in our problem, then this is the row that gives me any formulation that I want. And in this problem, our null hypothesis is mu equals to 35, and our alternative hypothesis is mu less than 35. Okay, and this is the third one, mu less than 35. Okay, so then with that, if I wanna construct run the test, what is the first thing I do? I put together the test statistics T0, which I already have, X bar, average of the sample, I have it. Mu null, I have it, 35 in my problem. S, standard deviation of the sample, I have it. N, sample size, I have it. Put everything here to find the test statistics, and then since my null hypothesis is mu less than 35, I have to pick the third row for the critical region to run the test. So I calculated the value of my test statistics. All I have to do is to calculate the value of minus t of alpha and n minus 1 from the table, do the comparison, and figure out if I'm going to reject the null hypothesis or fail to reject the null hypothesis. Okay. If I ask any question regarding calculating the p-value, here is the p-value. The formulation for the p-value. This is how you're going to calculate what is the p-value. You calculated the test statistics t null already. You get this probability from the table, and you're all good to go. If I ask you to calculate confidence intervals, here, this is the formula for confidence interval. Again, this row is when we need a test. We are running a test on mu. Sigma is unknown. Standard deviation of the population is unknown, and n is less than or equal to 30. So, and the third row is equal to the type of null hypothesis that I have, and this is the formula for the constructing the confidence interval. Okay.
So what if the population standard deviation is given also, but sample size is less than 30?
No, if the population standard deviation is given, is here. So you see, when sigma is given, you don't need to check for anything else. All set. If population standard deviation is given, you're all set. That's for sure Z. Everything is given. You don't need to worry about sample size. You see, you don't need to check anything else. Just pick the first row, pick the right formula, and go ahead.
Okay, got it. Thank you.
Sure. Yeah. So, and pick the right formula, plug the numbers, then you're all good to go. Okay. So that's that. Any question regarding this problem, guys? Okay. Sorry, mu less than 35. Let me show. Oh yeah, I get mu less than mu zeros. So we refer to the right equation. Okay, now let's look at this problem. So read the problem. I'll give you a minute or two. Read the problem. We're going to do the same thing. See what we have, what we don't have, what type of formulation we have to pick. Are you guys ready?
Yeah, I see that the mean is not known.
Okay, first tell me, what is the random variable of interest? What is
GPA
it?
of engineering students.
GPA of CPP. Okay, that's great. For this random variable, what am I trying to test? Is it something related to average of this random variable or something related to a proportion related to this random variable?
The average.
The average. Where did you see that?
It says that the average of GPA is 2.9, and we're testing the hypothesis
Yeah,
of the
so
GPA.
exactly. Everything you say, it's commonly believed that the average is this much. We took a sample, average of the sample is this much. So it's average, average, average. So, so this is a hypothesis test on average of this random variable. And let me copy this. And what is my null hypothesis? What is my alternative hypothesis?
H null equals 2.9, and alternative is mu doesn't equal 2.9.
Okay. It says that the population mean is unknown. However, it is commonly believed that the average GPA for CPP students is 2.9. And that's that. That's all it says. Then it says, oh, we took a sample, average of sample is this much and that much. But this is basically all we know, that it's commonly believed that the average GPA is 2.9. So here, my null hypothesis is that mu average of the sample is 2.9. An alternative hypothesis is that average of the sample is not. 2.9. Okay, so that's that. And okay, what are the other pieces of information that is given to you in this problem statement? What are the things you have?
Our population standard deviation is 0.4 and is known.
Very good. That's population standard deviation or sigma. That's population, not sample. Population standard deviation or sigma is given to us. Okay, what other pieces of information you have here?
N equals 16.
Sample size or n equals to 16.
And alpha equal 0.05.
Alpha equals to 0.05. Okay, what else?
X bar is 2.8.
X bar is 2.8. So we took a sample of size 16 students. Average of this sample of the students have a GPA, average of the GPA in this sample of 16 students is 2.8. And yeah, so the standard deviation of the population is 0.4. That's all my alpha, that's my null hypothesis alternative, and so forth. Okay, so now with everything you have here, with everything that is given to you here, okay, what is the very first thing that we have to recognize in every problem? If it's a test on average or proportion of a characteristic of interest, and that's average. Okay, that's out. What is the next important question?
Sample size.
Before that. Sample size comes to the picture only if
Population standard deviation.
yeah. So the next important question is that do I have population standard deviation or sample standard deviation? If I have population standard deviation or sigma, I don't need to worry about sample size at all. I worry about sample size only when I have sample standard deviation. That's when I need to check, do I have this less than 30 sample or more than 30 sample? Is it a small sample size or big sample size? If you have population standard deviation or sigma, you don't need to worry about the sample at all. Okay, and here you have the population standard deviation or sigma. So I don't need to worry about the sample. That question goes aside. So with that, knowing that I have population standard deviation and that I'm running a test on the mean, if I go here, okay, which row I have to pick?
First row.
First row, because it's a population mean test, and sigma, standard deviation of the population, is known. Okay, sigma is known. I know the value of the sigma 0.4. Here it says, and it is also widely known that for this population, sigma is 0.4. Even if it doesn't write sigma for you, it says it is widely known for this population, standard deviation is 0.4. You have to still be able to just understand from that statement, that's population standard deviation, that's sigma. Okay, now I have this. My null hypothesis is that mu equals to 2.9, and my alternative is that mu is not 2.9, the first in the line. So if that's the case, then I'm going to first put together my test statistics, Z null. I have average of the sample. I have mu null, 2.9, right? 2.9. I have sigma standard deviation of the population. I have my sample size. I put together the test statistics, and then these are my critical region. Then I check my test statistics with the minus z of alpha over 2 or z of alpha over 2 to find if I'm going to accept or reject, if I'm going to reject or fail to reject the null hypothesis. Remember, we never say we accept. We always reject or we fail to reject. Okay, that's my critical region. If I ask you what is the p-value, you use this formula to calculate the p-value. And if I ask you to construct some confidence interval, it's first row, and this is the formula for the confidence interval. Okay. For this test, let's assume I have constructed a confidence interval. Let's assume I have constructed a confidence interval, and let's assume this is my confidence interval. Let's assume I have constructed a, assume we have a 95% confidence interval as this. Okay, so that's my confidence interval. Tell me, given this confidence interval, what is your conclusion about the hypothesis test?
We reject the null hypothesis.
Because
It doesn't lie within the confidence interval.
when you say it's, you mean
The null hypothesis.
that the average that we hypothesize. We hypothesize that this average that we don't know is 2.9. However, here I construct a confidence interval. Can you tell me what is the meaning of this confidence interval? In one sentence, just tell me what this confidence interval means.
We can assume with a 95% confident. We can assume with a 95% chance that the hypothesized mean lies within this confidence interval.
Yeah, I would say 95% correct. I just won't probably use some of the words. So that's how I would say. You were correct. Perfect. Thank you. This is how I would probably make some little tweaks. I would say with 95% confidence, the unknown mu, the mu that I don't know, falls somewhere in this interval. That's what this confidence interval is. I don't know the average of the GPA of CPPS students. That's the unknown. We know that. However, this confidence interval tells me this average that you don't know falls somewhere between 2.95 and 3.3, 95% of the time. With 95% chance, it falls somewhere in this range. Now I'm asking you to check. Now I'm telling you, I hypothesize that the average of the GPA of a student is 2.9. And all you have is this confidence interval that you have constructed with the sampling and everything. So with this confidence interval, if you know 95% confidence, the average falls somewhere here, and I'm asking you if the average is 2.9, then obviously you're going to reject that hypothesis, reject the null hypothesis and say that with 95% confidence, average falls somewhere here. So I reject that average is 2.9. Okay. So that's how we are going to interpret. Let's assume I have calculated the p-value associated with this test, and let's assume the p-value is 0.03. How would you conclude if the only thing that you had was the p-value? Everything that you have here has helped you to calculate the p-value. So you have come here, you have put together the test statistics, you have the value of the test statistics, and then you have put together the p-value. You have done that. And at the end of the day, this is the p-value that you have calculated, 0.03. How would you conclude about the test if that's the only thing, if that's what you had at the end of the day? P-value 0.03.
We reject the null hypothesis because p-value is greater than or less than alpha.
Exactly. P-value is less than alpha, and that's always the recipe for rejecting the null hypothesis. Which is exactly what we also concluded if we had the confidence interval.
Professor, for this particular example, when we want to find p-value, in the formula is 2p z bigger than z naught. So would we write 1 minus 2p or 2 times 1 minus p, the rest?
You have to, so this is, so basically your question is about how to calculate this probability of p. Is that, can you repeat your question one more time? I want to make sure I understand.
Yes, so because like it's in the table, it's gonna be z less z naught. So in order to get that, we usually say like 1 minus the probability, but we have this 2 in front now.
Yeah.
Do we say 1 minus 2 or 1 minus p, the whole thing times 2?
You see here, this is the shaded area, right? So that means for every z we pick from this table, the probability that we find in the body of the table is the probability of z less than our value. Even if the z is positive, still it tells us probability of z less than this value. If that's the z, it tells you probability of a random variable is less than this value, no matter if z is positive or negative. Okay, so if here, here, if you want to calculate probability of z greater than something, then in the paper, in the table, you calculate probability of z less than that, and then 1 minus that number will give you this value.
Okay,
And
then we'll multiply. Okay.
And then multiply that by 2. So don't get confused about this. This is 2 multiplied by this probability. So find this probability first, whatever it is, however you are going to do it, and then multiply it by 2. This probability of z greater than something, and in the table, we always have probability of z less than something. So come to the table, find the probability of z less than something, and then 1 minus this number gives you this probability that you want, and then multiply it by 2. Does that make sense?
Yeah, thank you.
Sure. Okay. Let's go over this problem. What is our random variable of interest here?
Number of students finishing in 4 years.
I would say if a student has finished in 4 years, and then this random variable can get 2 possible values. Let's say 1 means yes, it has finished in 4 years, and 0 means No, that person has not finished in 4 years. And what are we interested to calculate? Something about average of these random variables, something about proportion of these number of students who have finished in 4 years. Like, what are we trying to find out here?
We're trying to find the proportion.
Proportion. And where did you get that idea? Like, which part of the problem helped you with that?
The first sentence, our claim is if 55% of the students will finish their education.
Exactly. If 55% of the students, that's immediately something like proportion, percentages, right? And so we are interested in this problem to test something related to a proportion of a characteristic of interest in the population. Okay. So my null hypothesis is that P, or proportion of the characteristic of interest, is what? Can you tell me what is my null? What is my alternative?
Your null hypothesis is that P is equal to 55 or 0.55.
0.55.
Yeah,
These
0.55.
percentages, right?
Yeah, percentages.
And my alternative would be?
The alternative is that P is greater than 0.55.
Yeah, if more than 55% of students will finish in 4 years. We are interested to test that if more than 55% of students will finish in 4 years. So I'm interested to know if P is greater than 0.55. And obviously my alternative, my null is that P is 0.55, and my alternative is that if more than 55% of students will finish in 4 years, okay? And then what are the other things you have in this problem statement? What other pieces of information is?
You have a sample size of 100.
We took a sample of size 100. What else? What else do you have?
And you have your X bar, or your number of successes.
Exactly. And that's X. So X here is number of success. Exactly. Number of students in the sample that have finished in 4 years. And that is 61. 61 of the students in that sample of 100 students have finished in 4 years. That's 61. And these two numbers are going to help me to calculate what?
P hat.
Oops, exactly. P hat, which is going to be 0.61 here. And then I have said calculate a 95% confidence interval of percentage of people or students who finish in 4 years. I had to mention that as well. But with that,
Professor?
Yeah.
Is another name for P hat also the population proportion?
P hat is the sample.
That's sample proportion.
Exactly.
Okay.
Population proportion is exactly what I want to know. Population proportion is the one that I don't know. This is equivalent to population average, mu, that we don't know. This mu is population average, I don't know, but I use sample average as a point estimate for that. Here, P is population proportion that we don't know. And I look at sample proportion, or P hat, as a point estimate for this population proportion. So sample proportion, or P hat, gives me a point estimate for P. Confidence interval gives me an interval for P. And test of hypothesis helps me to test some hypothesis if P is greater than something, less than something, equal to something, not equal to something. And the same story holds for the average. I don't know average of the characteristic of interest in the population. Mu, I don't know. But average of the sample gives me a point estimate for this unknown mu. Then I also construct confidence interval. I do the test of hypothesis to also be able to say more about that unknown average of the population. Okay,
Thank you, Professor.
of course. So with all of that, then the formula that we have to use is not in this, but that's module 8, part 3. Everything is here. Yeah, that's our test statistics. So I have X, I have N, I have P null. So I can easily put the test statistics together. And
I think it's after this.
I'm trying to find the critical regions. The confidence intervals. Yeah, so even if I asked you to construct a confidence interval, you have the p hat, you have the n. Based on the alpha, you will have z of alpha over 2. You have everything. As long as you know you are testing on p, what is the size of the sample, what is x, what is p hat, which is the sample proportion, what is z of alpha over 2 and stuff, just plug in the formula and you have everything. And a bunch of these things.
So for this formula, we're just looking for the lower bound and upper bound, right? We don't really use, like it says, the probability of the whole thing.
Yeah, exactly. It just says, oh, if you want a 95% confidence interval, this is basically what it means. But you're right. You don't calculate probability or anything like that. That's the lower bound, that's the upper bound, and that's all you need. If you want a one-sided confidence interval, that's the lower bound. If you want lower confidence interval, and if you want an upper confidence interval, that's the formula for the upper bound. Forget about the p 1 minus alpha, blah, blah. So these are the formula for the lower bound, upper bound of the confidence interval. So just put those in your cheat sheet and plug the numbers and you will be good. Let's say here, if I construct a one-sided lower bound confidence interval, and let's assume in that confidence interval, I say P is greater than 0.49. This is a one-sided lower bound 95% confidence interval. So with this confidence interval we have constructed. Yeah, for all these things, guys, that I give you examples, I make up these numbers. Just to say, okay, assume this is my confidence interval, assume this is my p-value. I don't know the exact numbers, so maybe when you guys calculate, you find different numbers, but I just wanna just give you examples that if this was the situation, how would you make the decision? Because that's what I want you guys to know or to learn. So let's assume this is my one-sided lower bound confidence interval, 95% confidence interval. Given this confidence interval, how would you decide about the test of hypothesis?
We have to calculate Z0, then we already can get Z alpha.
Let's assume I have done the calculations for Z null and I have constructed the confidence interval. And let's assume this is your confidence interval. 95% lower bound confidence interval says that P greater than 0.49, meaning that with 95% chance, I'm confident that P, the unknown proportion of Cal Poly Pomona students who will finish in 4 years is greater than 0.49. Which means
less than
sorry?
0.49, it's less than 0.05.
Okay. What is then your conclusion?
Reject.
Does your hypothesized P falls in the interval? What is your hypothesized P? Your hypothesized.
0.55.
0.55 is your hypothesized value for P. That's your hypothesis. does this value that you hypothesize fall somewhere in the interval? Somewhere in the confidence interval? Does that value falls in your confidence interval?
No.
0.55 is not greater than 0.49?
Yes, it is.
Yeah, it is.
It does fall, okay? So this confidence interval says unknown P falls somewhere greater than 0.49. I mean, I'm 95% confident that this unknown P is somewhere greater than 0.49. I'm 95% confident of this claim. It's somewhere greater than 0.49. And now you're telling me I'm thinking it's 0.55. Okay, 0.55 is greater than, I know it's greater than 0.49 and you're thinking it's 0.55. I cannot reject what you say. That's what it means. I fail to reject the null hypothesis because 0.55 is in the interval that I have constructed. Okay, so I have no reason to just say, oh, you're wrong. I cannot, I cannot say you are correct, but I cannot say you are wrong. So I fail to reject you. Just because your null hypothesis falls in the interval. And I know this interval, I know P is greater than 0.49, and your hypothesized value is in the interval that I think P belongs to. So I fail to reject the null hypothesis. Okay, let's see, someone has said, for this example, would we reject the population proportion is greater than 50? So we always say something about the null hypothesis, Carlos. We always say if we reject the null hypothesis or we fail to reject the null hypothesis. Right now, the null hypothesis says that P is 0.55. So that's what I accept. And I cannot say anything about P greater than 0.55 because here I say P is greater than 0.49, meaning that P even can be 0.5. P even can be 0.51, right? So really, I cannot say anything about this, that P is definitely greater than 0.55. Yeah, P greater than 0.55 is in my interval as well, but P less than 0.55 is in my interval too. If P is 0.49, if P is 0.5, they are less than 0.55. So this interval that I have constructed doesn't support my alternative all the way through. So all I can say is something about my null hypothesis, that null hypothesis is in this interval. So I fail to reject that. I fail to reject the null hypothesis. Does that answer your question, Carlos? Okay. We have passed the time, but if you guys just need, I think, let's do just one more. If you guys need to go, please feel free to go. But if you guys are around, let's look at one more problem. Guys, what is the random variable of interest?
Average heat evolved in calories per gram.
Exactly, not the average, the heat evolved, exactly. The heat evolved in calories per grams of a cement mixture. For this random variable, what am I trying to test? Is it something related to its average, a proportion of it? Like, what is it, the thing that I'm testing?
Testing the average of the heat, average heat.
Exactly. Average heat, is what we are trying to test here. Okay, now, what is my null hypothesis and what is my alternative?
Null hypothesis is 70 and the alternative is not 70.
Mm-hmm. The mean is thought to be 70. We think the mean is 70. And this is the standard deviation. We take a sample. and we wish to test if the average is 70, and it doesn't say anything else. And as you can also see here, for the acceptance region, it's a two-sided acceptance region, right? It has a lower bound and it has an upper bound. That's another confirmation that your alternative is a two-sided. So all I know is that mean is thought to be 70. So what is the alternative against it? That mu is not 70. It doesn't say anywhere in the problem that we think mu is less than 70, greater than 70, at least this, at most that. It doesn't say anything. So that's the alternative hypothesis. Now, tell me what other pieces of information you have in this problem set.
Standard deviation.
Okay, standard deviation. What is standard deviation? Sample standard deviation or population standard deviation?
The sample, or no, it's the population.
It's the population, because it says the mean is thought to be 70 and the standard deviation is 2. It's for the population. If it was sample, it would say, oh, we took a sample of size blah blah, and this is the average, and this is the standard deviation of the sample. But here it says it hasn't even gotten into the sample yet. So when you read this statement, this problem statement, you have to conclude, you have to know yourself that this is standard deviation is population standard deviation. Okay. Population standard deviation, or sigma is 2. And get that. Okay, what else do you guys have here?
Sample size is 5.
Sample size is 5. What else?
And we have the acceptance region.
And we have the acceptance region as well. Okay. I think you should also have the
X bar.
yeah, maybe, or maybe not, but let's assume, I don't know, let's assume I also give you the average of the sample. For X bar is, let's assume it's 73. I'm just making up numbers. Okay. So now with everything that we have here, we are looking at the average and everything. Tell me which formulation I have to pick. First of all, it's average of a random variable. We find that. The second question, do I have population standard deviation or sample standard deviation? I have population standard deviation. And if that's the case, then which row I have to pick?
The top.
At the top row. If population standard deviation or sigma is known, we pick the top row and we are not worried about sample size. Okay, so as and then we pick whatever formula we need depending on the question that we have been asked. Now I want to ask you this: if sigma population standard deviation is not known, however the sample size is greater than 30, how would you approach the problem? Is it this one? Mm-hmm. If sigma is unknown, but n is greater than 30. Then we pick the top formula The only thing is that instead of sigma, we put S because I don't have the sigma. Sigma is unknown, but the sample size is greater than 30. So still, instead of sigma, since I don't have it, I have to put sample standard deviation S. However, this has a Z distribution and not a T distribution. So everything stays the same. Just instead of sigma, put S. That's the only change you need to make.
Also, this question is asking for alpha, but like this formulas doesn't give us the alpha.
For the alpha, you have to just do the calculations using the definition of the alpha. Remember alpha or type 1 error, the probability of rejecting H null condition that H null is correct. So just write down that definition. So I'm not going to solve this for you guys, but probability of rejecting H null if H null is correct. And rejecting H null, it gives you the acceptance region. This is your acceptance region. So rejecting H null means if sample average is not in this range. So if sample average is, okay. So probability of rejecting H null while H null is correct. We say that this is acceptance region where when we are not rejecting H null, if the sample average is between 68.5 and 71.5. However, I reject H, and that's the scenario under which that's my that's my acceptance region. So if I want to reject H null, I have to look at the scenarios when sample average is less than this, or it's greater than this, is out of this range. If it's between these two numbers, I'm going to fail to reject H null. I'm not rejecting H null. I reject H null only if sample average is greater than 71.5 or is less than 68.5. That's the rejection region. And that's what I wrote here. When sample average is less than 68.5 or sample average is greater than 71.5, given that H null is correct. H null is correct, meaning that mu is 70. And then do the calculations. You have the X bar, you have mu, X bar minus mu divided by sigma over square root of n. You do the calculations for the Z and you go from there.